Solutions to the perfect problem 1 for Math 111. We're asked to simplify this huge mess of a complex rational expression. Okay, one thing to point out here is that we have a difference of fractions divided by a difference of fractions. Maybe that's the messiest looking thing in this whole problem. If it were just a fraction divided by a fraction, we can deal with it. But since we kind of have a fraction minus a fraction over a fraction minus a fraction, we can't immediately deal with it. But we can figure out what to do by making the numerator of this big fraction all one fraction. And what I mean by that is finding a common denominator up top here. Similarly, we'll want to find a common denominator down here in the denominator of the big fraction. And this guy we'll just leave alone for a long time. I guess we can factor out x squared plus x minus 12 into x plus 4 and x minus 3. But then really we're just going to leave this guy alone for a long time and work on this side. So let's see, what should we do here? We want a common denominator between 1 and 4 plus x. So that's going to be 4 plus x. So that means multiply this side by 4 plus x over 4 plus x. And multiply this side by 1 over 1. Don't even have to write it. Down here our common denominator will be 3x. So multiply this side by x over x, and this side by 3 over 3. And what that has done is given us a common denominator up top. Let's see, we'll have 4 plus x times 2, which is 8 plus 2x, minus 2. So 6 plus 2x divided by 4 plus x. So what I did is I wrote the denominator once and I combined the numerators after I distributed this 2 through. Probably could have shown that in 2 steps, but hopefully that's okay with everybody. And in the bottom here, x times x is x squared, and 3 times 3 is 9. And we can just write our common denominator once, 3x. And this side, again, just leave it alone. We'll deal with it later. So let's see, maybe I come over here now. Finally, we have a fraction divided by a fraction. It's something that we know how to deal with. It's the same as multiplying this fraction by this fraction, except this bottom one you have to flip over. You multiply by the reciprocal of the denominator. So let's see, up top here we have 6 plus 2x. Get a little clever, you can factor out a 2 there, and you have 2 times 3 plus x divided by 4 plus x. So I just copied the numerator of our big fraction here, except I factored out a 2 from the top. Then instead of dividing by this, we can think about it by multiplying by the reciprocal of this. The reciprocal of this is 3x divided by x squared minus 9. But x squared minus 9 is a difference of squares. So we can write that x minus 3 times x plus 3. And so we've rewritten this in a convenient form. Again, leave this guy alone. We'll deal with it eventually. All right, moving on. Something that we have up here that's kind of nice. We have 3 plus x and x plus 3. Addition, it doesn't matter what order you do it in, right? 3 plus x is the exact same as x plus 3, so we can cancel those guys out. And then if you put together what we have, 2 times 3x is 6x. And in the denominator we have x minus 3 times 4 plus x. 4 plus x is just the same as x plus 4 times x minus 3. And if you notice, this denominator is now the exact same as this denominator. So instead of writing this plus this, we can just write the denominator once and add the numerators, 6x plus 12. And I suppose there's a 6 in both of these guys, so if we thought it was simpler, we could write the numerator as 6 times x plus 2 and leave the denominator alone. It's a good idea to factor out the 6 because then we can look and see if this x plus 2 will cancel with anything. In this case it doesn't, so that's as far as we can simplify. And we'll call that thing our answer to the first perfect problem.